Good morning everyone. Today we are discussing about how to add two polynomials which are created by using the linked list. Let us consider the first polynomial p1 equal to 2x to the power of 6 plus 7x to the power of 5 minus 9x cube plus x square and 6x. We know that the polynomial is the combination of set of algebraic terms and each term has the two parts. One is the coefficient and another one is the exponent. So the following is the linked list representation of the polynomial. Each and the here the starting node consisting of the first term or the first node of the polynomial. The node here has three parts. The first part consisting the value of the coefficient, the second part consisting the value of the exponent, and the third part has the address of the next node where the next term of the polynomial to be stored. So this is the actual linked list representation. I am considering the first node address is 100 which is stored in the starting node. The second node address is 200 which has the stored in the first node link part, and the second node has the coefficient value 7, exponent value 5, and its link part has the third node value address value 300. The third node has the coefficient value minus 9 and exponent value 3, and link part has the fourth term or fourth node address, that is 400. The fourth node has a coefficient value 1 and exponent value 2, and the link part has the fifth node value 500. The fifth node has the coefficient value 6 and exponent value 1, and after that one there are no terms in the polynomial, hence the link part has the null value. In the same way, I am considering the another polynomial t2 equal to x to the power of 5 plus 5x cube plus 2x. For this polynomial also the following is the linked list representation, right? It has the polynomial has the three terms, hence the linked list also has the three nodes like that, right? Whenever we are adding the polynomials, we should consider that we are comparing from starting onwards, we are comparing the exponent values from both the polynomials. Suppose there are three cases, the exponent values are the same, we add the coefficients and then any one of the exponent value from any one of the polynomial is added to the resultant exponent value of the particular coefficient. Otherwise, suppose the highest coefficient, the highest exponent value and its coefficient is transferred to the resultant polynomial. So here let us consider in P1 the first term is 2x to the power of 6. We are going to be look it into there is any x to the power of term in the second polynomial. Here we observe that x to the power of 6 term is not there, hence 2x to the power of 6 is the highest exponent term. Then we can add it to the resultant polynomial P3 2x to the power of 6, and then we are move one step forward in the first polynomial because the processing of 2x to the power of 6 is over. Then we go to the 7x to the power of 5 term, and we can set in the second polynomial any x to the power of 5 term. Here 1x to the power of 5 or simply x to the power of 5 term is there. In P1 x to the power of 7x to the power of 5 term is there. The total value is the both are positive, 8x to the power of 5. We are adding these two terms in the resultant polynomial P3, and then we move one step or one term forward in both of the polynomials. The next term in the polynomial is P1 polynomial is minus 9x to the power of 3. We set any x to the power of 3 term in second polynomial. In second polynomial there is a 5x to the power of 3. In first polynomial 9x to the power of 3. By adding these two, we are getting the minus 4x to the power of 3. The value is added in the resultant polynomial P3. In the same way, we move forward one step or one term forward in both of the polynomials. The next term is x square. The x square is not in a second polynomial. Simply we add this to the resultant polynomial. And the next term is 6x. In the second polynomial 2x, both the exponents are the same. We are adding the 8x into the resultant polynomial P3. Now I would like to write some code to explain the addition of polynomials algorithm. Here I am write void add poly, and I am consider P1, P2 and P3 are the polynomials which are already created, and P1, P2 has the data. The P3 is the empty list initially. Right? The P1, P2 and P3 are the node type. So when I am adding the two polynomials, I start from the first node to the end of the node in first polynomial and first node to the end of the node in second polynomial. So for that reason, I write while loop, the P1 link not equal to null and P2 link not equal to null. Right? That means P1 is forward, that means transfer from first node to the last node, from first node to the last node. In the same way, P2 is also traversing from first node to the last node. So I am write P1 link not null and P2 link not null. And then to compare the exponents, I write if P1 exponent equal to P2 exponent. When both of the exponents are equal, simply we add the coefficients. So the resultant coefficient is stored in the P3. For that reason, I write P3 coefficient equal to P1 coefficient plus P2 coefficient. P3 exponent equal to any one of the polynomial exponent P1 from P2. Here I consider P1 exponent. Right? Next, P1 equal to P1 link and P2 equal to P2 link, because after adding these terms, here let us consider 7x to the power of 5 and in P2 x to the power of 5. The total value is 8x to the power of 5. We move one step forward, that is next term is 9x cube. Here the next term is 5x cube. So for that reason, here I write P1 is forward to the next term. In the same way, P2 is also forward to the in the same way. This if condition checks when both of the exponents in both of the polynomials are same. Suppose one of the exponent is higher than the next exponent in the polynomials, what we do? I am writing the else part. If P1 exponent is greater than P2 exponent, what we are going to do? Because we add the highest exponent coefficient to the result. So for that reason I write P3 coefficient equal to P1 coefficient, P3 exponent equal to P1 exponent. After adding this term, I am move the P1 link to the next, because the P1 move one step forward, go to the next node or go to the next term. So I write P1 equal to P1 only. Suppose the exponent in the second polynomial P2 is higher, then how we will do? I am write else if P1 exponent less than P2 exponent. Now the P2 exponent is greater than P1 exponent. Hence the terms in the P2 is added to the resultant polynomial P3. So the P3 coefficient equal to P2 coefficient, the P3 exponent equal to P2 exponent. After adding the term P2 term in the resultant polynomial P3, the P2 term is moved one step forward. For that reason, I write P2 equal to P2 link. This is the end of the if and else, and this is the end of the algorithm. This is the actual code, the entire code, how we are going to be add the two polynomials. Right? We are declaring the two polynomials P1, P2 and empty polynomial P3, and these polynomials, the first two polynomials are traversing from first node to last node, and when the exponents are equal, coefficient are added. Otherwise, the largest exponent coefficient is added to the resultant polynomial. Thank you.